Okay, so the last couple of days we focused on mostly linear types of graphs. That's a graph with one single linear function. Okay, and those are all governed by y equals mx plus b. Okay, but there's another kind of graphing question that you could get, and that would be an irregular or nonlinear graph like this one. Okay, we still have to be able to solve for things from a graph that doesn't have a y equals mx plus b function on it. Okay. So what I want to look at today are some position versus time graphs that aren't y equals mx plus b graphs, okay, so that we understand the kinds of things we might be asked and so that we know how to do them. And then next week, we're going to move on to velocity versus time graphs and acceleration, have another lab, and then we'll be done with the graphing and we'll be moving on to energy after that. Okay, so what I would like you guys to do is answer those 4 questions. Okay, from this position versus time graph. Remember, okay, that formulas that can apply for a position versus time graph are that displacement is final position minus initial position. Velocity is displacement divided by time, which could also be final position minus initial position over time, and speed equals total distance over total time. Okay, those are the kinds of things to keep in mind when you have an irregular graph, because obviously you can't use y equals mx plus b if you have something doing more than one thing. Okay, all right, I'm going to give you guys a few minutes here to get a little bit ahead, and then we'll walk through some of the solutions here. Okay, forward. Okay, so we're looking for the displacement between 4 seconds and 15 seconds. Probably our best bet for a formula is the first one. Okay, so what I've got to find then is what was my final position, so that would be at 15 seconds, so looks like -1. Okay, so we'll start out with d equals -1 minus my initial position, which at 4 seconds is -10. Okay, so -1 minus -10? 9. Well, yeah, positive 9. Okay, meters. Okay, I mean, it makes sense. We went from -10 to -1. That means we went forward 9 meters. Okay? All right, how many people have got number 2 done? Okay, I'm going to give you 1 more minute to finish up number 2, and then we're going to walk through that one. Okay, so does distance care whether I go forward or backward? No, so I just have to worry about how far I go in each section of the graph. Okay, now I can do this like one piece at a time, or I could just do all the up and all the back. It doesn't really matter, you're going to get the same answer either way. Okay, so for this section of the graph, I go from -20 to -10, so that's 10 meters. How far do I go here? No meters. Okay, all right, and then from here I go from -10 to +14, pretty sure that's 24 meters. How far do I go here? No meters. Okay, and then I go from 14 to -1, pretty sure that's 15 meters. Okay, so 39, 49 meters? Okay. Do I need a vector on that? No. Distance is scalar. Okay, give you a few more minutes on 3 and 4. You've done most of the heavy lifting for 4 already. Okay, so those 2 shouldn't take you too long. Well, let's look at 3 and 4 here. Okay, should I use this formula here for number 3? Okay, makes the most sense, right? I'm supposed to calculate velocity. I have a position versus time graph. I should probably use the formula that has all the stuff that would be on the graph. Agreed? That's the process you're going to need to go through as we go further along in the unit. Okay, what do I have? What are some formulas that have what I have in them? How can I use them to get what the question's asking for? Okay. All right, so for this one here, if I want to calculate the average velocity, okay, I'm simply going to go final position, -1, minus initial position, -20, okay, and divide that by the total time, which is 15 seconds. So we're looking at 19 over 15. So what does that come out to, guys? Sorry, I forgot to fire up my calculator. 19 over 15? 1.26. 1.26, okay, and we should have a positive on that. Meters per second. Okay, it is a positive number. When I did my displacement calculation, I got +19. Okay, all right, questions on number 3? See a few people looking at that with a crooked eye. Okay with what I did there? All right, now for number 4, I said you've already done most of the heavy lifting for number 4. If I want to calculate average speed, I need the total distance and the total time. So the heavy lifting was calculating the total distance, which is what we did in question number 2. All right, so we're going to take our 49 meters and we're going to divide it by 15 seconds. Okay, so 49 divided by 15. All right, so we're looking at 3.3 or 3.27. Okay. 3.27 meters per second. Do I need a vector on that one? No.
It asks for 0 and 10.
Oh, sorry, between 0 and 10 seconds. See, I'm just so focused on later today. Okay, my bad. Not that number. Okay, between 0 and 10 seconds. So 10 seconds is right here. So we still did most of the heavy lifting. It's not 49, it's 34 divided by 10, which is 3.4 meters per second, okay, instead. Sorry. All right, questions there? Okay. How important is it to read the question carefully?
Very.
I'm such a hypocrite. I tell you to do that all the time, and then I don't do it and demonstrate not doing it. Okay. Where is the other position time graph? Doesn't like this lesson. There's too many big pictures in it. Oh, now I can. Because it didn't put all the grid lines on. Okay, the y value of that flat line there, okay, is -6. And the y value of this is 8. Okay, just so you know where the top of those peaks start and end. And then for whatever reason, I put the x-axis way down here instead of on the x-axis, so the numbers are down below. Okay, but that's the x-axis, that bold black line there. All right, give those ones a try there. They shouldn't be too tough. Okay. So let's look at average velocity here. Okay, would this be a good formula to use for average velocity for this graph?
Yes.
Definitely. Okay, because that's the stuff I can read off of the graph I was given. Right. My final position was -6. Okay, initial position was 0. The whole trip took 9 seconds. Was that 0.6 repeating? Right. Meters per second, and it is negative. Okay, we do end up behind where we started. Okay. All right, average speed. So to calculate average speed, I need the total distance and the total time. I already have the total time, 9 seconds. Okay, I just need to figure out how far this thing went. Well, it went up to 8, then it came back down, so that's another 8, and then it went another 6. Okay, so 1622. Okay, so we're looking at 2.3, something like that. 2.4. 2.44 meters per second. Okay, are those terribly difficult?
No.
No, but that's the kind of thing you could easily see on next week's quiz. Okay, I would say that next week's quiz is probably going to have a combination of velocity versus time and position versus time graphs, because we're going to go over velocity time next week. Okay, some of them are going to be y equals mx plus b, and some of them are going to be irregular like this. Okay, all right. Okay, I'm actually going to bring up the smaller version of this so you can see it better. Okay, so on page 7, guys, of your workbook for this unit, you're gonna see this graph, okay? And then there's some questions that ask about it on the following page, okay? They start out super easy, like just basically reading numbers off of the graph, and then they ask you to do a few calculations after that, okay? I can show both at the same time. Let's just skip ahead to okay, I want you to do question number 4 there using the graph, okay? Displacement between 2 and 4, displacement between 4 and 8, displacement between 12 and 16. That's probably not going to take you very long. Okay, then I'm going to show you some other questions to do with that particular graph. In your digital workbook, there are a ton of graphing questions. We're not going to get to all of them. So if you want more practice, that's where you need to look. Okay, so in that workbook that's on Google Classroom, okay, look in there if you want extra graphing questions. Okay, so if I want to calculate displacements, okay, displacement is final position of the object minus the initial position of the object. So between 2 and 4 seconds, it goes from 50 to 4, okay, so that's going to be negative 46 meters, okay, for the first one, negative 46 there. And then from 4 to 8, so we start at positive 4 and we go to negative 33. Okay, so that's going to be negative 37 meters. Okay, and then we go from 12 to 16 seconds. So at 12 seconds, we're at 20, and at 16 seconds, we're at 12. Okay, so that should be, so 12 minus 20 is negative 8 meters for that one. Okay, everybody all right with that? All right, and I want you to do number 8 there. Okay, total displacement for the entire trip, total distance for the entire trip, average velocity for the entire trip, average speed for the entire trip.
On the test, if we don't put like the little vector sign, would we lose a mark?
Absolutely. If it's a vector quantity and you don't put a vector on it, it's wrong.
Okay.
Now, sorry, that's a good question. And on that note, okay, obviously on this graph, the vectors are positive and negative because we're clearly given negatives on the graph. Occasionally, a graph will do something like this. It'll label this side as position in meters, and then it'll say north. Okay, so if I give you a graph that says that, if you get a negative value, do you write negative or do you write south?
So.
Okay, because and it's a trick. It comes up. Okay, is something to be on the lookout for. That's why we have to label our axes clearly. Okay, it's position in meters north. Okay, then you have to give me north and south. Okay, whatever direction it gives you is telling you the positive direction. Okay. Okay, well, let's have a look at total displacement for the entire trip. Okay, so total displacement, we always calculate the final position, okay, minus initial position. All right, so our final position is -2. Okay, our initial position is 30. Okay, so our total displacement is -32 meters. All right, everybody okay with that? All right, can I do D now? Right. Or sorry, C. I can do C now, right? I can do average velocity. So, okay, might as well just do average velocity right now, simply because I've got all of the numbers for it. Okay, it's going to be 32, -32 meters. divided by 18 seconds. So like 1.8 something. 1.7. Okay, so negative, okay, 1.78. What are my units for that? Meters per second. All right, so we did the two vector ones. We did displacement, we did velocity. Now we got to do distance. Distance is always a lot more work because you have to look at how far did it go, not just the beginning and the end. Okay, so as kind of a quicker way to do this, rather than doing every time the line changes direction, I kind of just go anytime it's going up, then back down to the x-axis, and I kind of do it that way. So, okay, in this first section here, I go from 30 to 50, which is how far?
20.
Okay. Then I know from here it goes all the way down to the x-axis, right to here. From 50 to 0 is 50. Okay, then from here down to its lowest point, which is negative 42, should be 42. Okay, and then I'm going to go back up to the x-axis, which is another 42 meters. I always do it the easiest way possible, right? There's no sense in doing extra work. Okay, so then we go from 0 here to our maximum value, which to me appears to be 27. Okay, so that section there is going to be 27. And then we go all the way down to 0 plus 2 more is 29. All right, so we got to add all of that up. Okay, 29 plus 27 plus 84, okay, plus 50 plus 20. All right, 210 meters for our total distance traveled. Okay, did I do all the heavy lifting for D?
Mm-hmm.
Yeah. Okay, what do I have to do with this number?
Divided by the second.
Divided by time. Okay, we know the trip takes 18 seconds. If I want to calculate average speed, it's total distance, 210, divided by total time, 18 seconds. So we're looking at 11.67 meters per second for our average speed. So 210 meters divided by 18 seconds, 11.67 meters per second. Do I need a vector on that one? No, speed is scalar. Okay? How are we feeling about those? Okay? That's where I was looking. All right, last one we're going to do, okay, is this one right here. Okay, that's as big as I can make it, guys. Okay, give that one a try there. Okay guys, let's take a quick look at this one here. Okay, so for total displacement, we always do final position minus initial position. Our final position is positive 0.5 meters. Our initial position is positive 0.2 meters, which means the difference is positive 0.3 meters. Okay, that's our total displacement. Okay, total distance traveled, well, we go from 0.2 to 1, so that's 0.8. And then we go from 1 down to 1.5, or to 0.5, so 0.8 plus 0.5 is 1.3 meters. Okay, no vector on that, it's scalar. All right, then to get average velocity, we already did the total displacement, it's positive 0.3, we just divide that by the total time, 7 seconds, okay, and we get positive 0.04 meters per second, and then for average speed, total distance, the 1.3 meters we already calculated, divided by 7 seconds, should give us 0.19 meters per second. Okay, honestly guys, I wouldn't put stuff much more difficult than the things we've done today on a test or a quiz. Okay, that's the extent of what you're going to see. Okay, now something we haven't done today but we did before that could come up on a quiz or a test about graphs is interpretation. I could just give you a picture of a graph and ask you what's happening. in section 1, in section 2, and you'd have to identify it's not moving, or it's moving backwards at a constant velocity, or it's accelerating forwards, or whatever, okay? That's something we didn't go over today, okay, but it is something that we've gone over before and could be on. All right, hope you guys have a good, long weekend.
Thank you.
Shovel snow for your neighbors. Do a good deed. It's supposed to snow quite a bit Friday, Saturday.